Hello everyone. In this episode, as I promised, I will start working on my reflection utilities. Now, because we are working with reflection, I'm sure that I will use system.reflection, but I think ReSharper will add the usings for me. So public, not public actually, a private list, and all of them are statics. So list of string, and this guy is asms or assemblies. Okay, and right now I will make a new list so that it won't yell at me that it's null. Then a private static read-only dictionary, and we don't need it, the serialized version, because this is not serialized, string, and a type inside system, and we call it cache equals to new dictionary of that. Now I will have different basically methods. All of them are statics. All of them are dealing with reflections. So the very first one is when we want to get a value from a member info, and we want to have a member info. We should have a member info actually. So we say public static bool can get value. So it means that if the member info there, that we call it info, and we want to see basically in this class, and that space, okay, we want to see if this member info has a get method inside the itself. This member info most of the time will be a property, okay? So we want to see if that property has a get, basically. So we say case, we need a switch first, switch on the info dot member type, okay? So we say case, and you see that we have a bunch of things. What we want is the field first. If that's the case, if we have a field, well, each field by default has a getter, so we return true. The next case is method. Method, no, actually it's a property, okay? And we say return. Now we want to cast the info to a property info first, and then each property info has this Boolean method can read, and we just want that, okay? At the end of the switch we return false, because the member info we sent in is not a field or a property, so it doesn't have any get method, basically, okay? We want the same, but we want to see if we have a set method. So if it's a field, again it will return true. If it's a property, can write, okay? So why can read and can write, and why get value and set value? If you use reflection and type, I mean output the member infos and their methods, especially methods on member infos, you will see that each property has a method for itself called get value and set value. Basically, when you are doing something like get semicolon, on a property, you are just calling that get value behind the scenes. And when you are typing set semicolon, you are calling that set value property. A set value, a method on that object, basically. So if you have a get method, the member info and here property info has a way for seeing if you have a get method. And this is the set method. Okay? So after this, we want basically public static that returns a type, and we call it find type. Now here we will add a string called name, what we want to do, we say if first assemblies equals to null. So if the assemblies are null, and that is why I didn't assign these guys at the start. So right now it's null. Okay? Can we null? Well, I know it's null. So if it's null, then we want to go and get all the assemblies inside everywhere. How we do that? We say assemblies equals to new list of a string first. Then we say assembly array, we call it as ASMs, equals to app domain dot current domain dot get assemblies. Okay? This will return all the assemblies inside your Unity projects. And I don't mean just this solution. Let's say that we have 10 DLLs and then our own scripts. So we know that scripts will be assembly-C#, I think. And those DLLs, well, we don't know. But app domain current domain means the Unity project itself. It will look inside that project. It will find that 10 different DLLs. It will get the assemblies names inside those 10 DLLs, add them here. Cool. So we got our assemblies. So we say for each inside ASMs var ASM for assembly, we say assemblies dot add. Now ASM, each assembly has this full name, and if you read the IntelliSense, it says gets the display name of the assembly. But it's not just the display name. It's somehow the qualified name of the assembly. Okay? After that, we loop through our assemblies var, and we call it assembly. Cool. We get the type. So type, and I didn't create it yet, so we want it here. Type. Okay. So type equals to type dot get type. Where did I define this guy? Oh, at the top. So we say type cache, or we called it cache, yeah, dot try get value, and that is the name we want out to type. Okay, here, before doing anything, we want to see if we have it. So we say if reference equals the type and null. Basically we are saying if the type is null, now do all this Okay, and at the very end of it, we return the type. The type. Now, this whole thing may blow on our face. So before anything, I will add a try and cache system. So here, paste it. So we are trying to get the type. If we failed, however, we return null. Okay, so we are basically preventing our try cache exception. And before doing that, I should be able to say debug in Unity engine.log error DE, and we call exception E. Okay, so we sent the exception to the Unity debugger and Unity console actually, and I want to do something here, and I want to say reflection utilities reflection utilities. Come on, work. Can't find the type with the exception, and we plus to E. Okay, so that we know where that exception came from. Now, here, when we are getting the type we want, remember we sent in a name, is name plus a comma plus assembly. So for example, if I sent in FA, it will look for FA comma, for example, utility.dll, the assembly of that, of course, whatever the assembly name is. Then we say if not reference equals the type with null. So if the type is not null, we break. We found the type. Okay? Now, if reference equals the type with null, so if the type is still null, means that this sort of trying to get the type didn't work. Now we need to do it in another array, basically. So we go for an each loop again inside our assemblies. We say string temp equals to assembly dot substring 0 comma the assembly dot index of comma and string comparison ordinal. Okay, what did I do? In the assembly, I'm getting the first part of the assembly before the comma, basically. Then we say type equals to type.getType of the temp plus a dot plus name plus a comma plus the assembly. So basically, I separated the first part of an assembly name, I added a dot and our name, then I added the rest of the assembly name there. Okay? That is what I did. Now, after that, we say if reference equals type with null, and if not reference equals to null. Then we found our type, we break. At the end, we say if reference equals type with null. So if the reference is if the type is still null, then we return null. Otherwise, we return the type. Okay, now what if the assembly is not null? Because all this happened inside the assemblies if it's null. Now, we forgot something. We want this to be here. Bam. Okay? So, that was my bad. Okay? Now, this happens if our cache didn't have the type. So, if the cache didn't have the type, we check if assemblies equals null, we get all the assemblies. After that, inside that assembly, we look for the type. If we have the type here, we need to put that type inside somewhere. Where to put? Right here. So if we found a type, because if it's null, then we don't want to cache the null, but if we found the type, here we say cache.add the name with the type, and then return the type. The next time we are looking for the same type, it should be here, so it just don't work on this if, and it will just well, it should be outside, it should be here. Okay, and it just returns the type. If it wasn't there, we had cached it. If it was there, we just read it and return it. If anything happened during this process, means any problem happened on the system, we just throw an exception and we return null. Cool. Now, we checked if we can get a value or a set value. How about if we actually get a value and set a value? So public static, it returns object by default, get field value on an object obj and the string name of the field that we want to get its value. If object does not equal to null. Okay? If it's null, then we simply return null. If it's not null, then we want a field info, and we call it field equals to object dot get type. As always, when you get the type, you hook to the object inside memory, then you can get field with the string name. Okay? After that, we check if the field does not equal to null. So if we found the field with that name, we return field dot get value of the object. So if you remember from our item system, you remember that when you are getting a value on a type, you need to send in back the object itself as the param. Okay? Basically, we are invoking a method on that object, on that field. That's how it works. If the field was null, however, well, we return null. Okay, how to set a value? So public static, come on, static, and here we return a bool as set field value. We first want the object obj, string name, and an object as the value. Okay, you could call void, but I'm returning a bool so that I know if I was successful on the field assignment or not. So we say if obj does not equal null, otherwise returns false, return false. So it was null, we couldn't assign anything. Okay, if it's not null, basically first we want to get the field, and if the field is not null, that part is the same. We then say if it's not null, field dot set value on the object, the value, and we return true. So if the field was again null, then we are returning false. Okay, now what if we want to get the type of a member? So we say public static type get member get member type. Okay, here we send in a member info then we want to switch on the info dot member type, the first case, and you see we have tons of things. Well, we don't want the constructors, we don't want the customs, we want event, fields, methods, and properties. So let's start with the event. If that's the case, we return, and we typecast to event info, our info, and then event, come on, not that, return, god damn it, we typecast to event info, our info, and we want the event handler type. Cool. Then the case of field. If it's a field, we want to typecast to field info, and we want to get field type. Case method, we want to typecast to method info, our info, and we want the method type, not member type. What do we have here? Dot member type, not, well, basically we want the return type there. And god damn it with my indents. Then case, if it's properties, we return, we want the property info, and we want the property type. Okay, if none of them, then return null. You may notice that I purposefully didn't go for type info. Let's see if I can find something for that. So the type info, and we don't have that, so type info dot base type, declared type, reflected type. Which one? declaring type. Okay? Although if it's a type info, then you know it's redundant, but for the sake of complicity. Well, on custom type case custom, do we have anything on custom? Attribute data, format exception, blah. And we don't have custom info. So that was why I didn't have it in my notes. And on, of course, constructors, we don't need type for a constructor. So now we get a value for a field. If we want to get and set values values on members, we need to do it different way. Public static object get member value. We want an object called obj. No, not really the object itself. Yeah, we want the object, so object obj, and the member info, we call it info. Okay? So we first check if the member, we call it if the info equals to null, or the object equals to null, then we return null. Okay? Otherwise, we want a try catch system. So try, we want to switch based on info dot member type. If the case is filled, we want to return the typecast to field info of info dot get value on the object, and that's it. If the case is property, we want to typecast it to property info, but you may notice that now we have a problem here, because property info accepts an object array as index, and most of the time my properties has no indexing. Other than that, return null. Well, case, I'm not sure if I can use the method. Come on, type method info and get value. Now we don't have that. Let's see dot. We have the return type, return parameter, well, we can invoke it, but that's not good. Okay, so we can't do it on methods. And inside of the cache, we say debug.log error, and we want the same error logging. Where was that? Okay, here is the error on get type. here is on get member value. Get member value. And exception is E. Okay. Now, we got the value. How about we set the value? So we say public static, not string, goddamn, and static. And we want a bool again. Set member value. And again, we want the object obj and member info, and this time we want the object as value. Now we say if info equals to null, or the object equals to null, return false. Otherwise, we go into the try cache, and inside try, we want to switch based on info dot member type, case, or field. If that's the field, then we want to say first typecast to field info, our info, then dot set value on the object with the value we send in, and you see not null, the binding flag is null. Okay. What is wrong with you? Oh, return true. Now, what are you? Why are you not happy? Set value. Oh, object and value. Sorry. That. Now, case property. Basically, we are casting to property info, setting the value, and the indexing now is null. That was why I was missing something. Now in exception, and well, otherwise we return false. If the exception happened, we want this, and this is the set member value, and now I found something here. Oh no, I'm returning null. Cool. So now, how about we get the public fields and properties? So we say public static. We return a field info array, and we say get public fields on a type, and we call it type. Basically, we return type dot get fields, binding flags. Now you can find tons of snippets on web online about this part, but what we want is the public, and we OR it with binding flags of instance. Same thing for our properties, but well, guess what? We want our property info array and get properties of that binding flag. Get public properties. Thank you. So now, if we want to get the fields and properties at the same time, we want public static fields and properties by themselves are a list and they are member info. We could send in an array. We can't because, well, guess what? We are adding different things inside one array. So get public fields and properties. I don't say get public members because part of the members are methods. We are ignoring them, so type. Here we say list of member info. We call it list equals to new list of member info. After that we say list dot add range of, we call ourselves get public fields of the type, and list dot add range of get public properties of the type, and I just found a typo there. Public with capital P. Okay, and at the end we simply return the list. So we got our properties, we got our fields. Because field info and property info are subclasses of member info, we are returning a list. Now, these are the basic methods. After that, I will have a region. I will say try compare to, and I will end the region. I won't add it here now because I'm not sure what type of things I want to compare to each other. And I have a region for try get values and end a region. Now this part is something that I know what to do with. So public static bool try get bool from an object, we call it O, and we output it on another bool calling B. Okay, so for example, you had seen try get value on the lists. This is how they are doing it. At the same time they are returning something. Okay, so they are setting something and returning a condition. So we say if O is bool, well, we simply say B equals to typecast bool the O, the object. Then we say else if O is int, then we say B equals to typecast to int the O, not 0, O, and we want to compare it does not equals to 0. So if it's equals to 0, it will be false, otherwise it will be true. Else if O is float, god damn it, O is float, basically we have the same thing, but we typecast it to float. Okay, and 0f. Now this says that you can use a comparison to epsilon. I don't like it, so don't show it. Thank you. Then we say else if O is byte, B equals to typecast it to byte, and byte behaves like integer, so it's 0 and 1. Else if not bool dot try parse the O dot to string, and we out it to B. Then we return false. Okay? Other than that, we return true. Now, what did I do on this last section? Here, I'm assuming that I am sending a string. So, I will try to parse the string to a Boolean. If that's successful, well, I assigned it to B at the same time. If not, then we are returning the false. Now you see why bool out bool can work. This is, for example, bool out bool. We are returning a Boolean so that we can use it in if statement. At the same time, we are outputting our try parse inside another Boolean. Okay. Next, try get public static, and all of them are returning bool. So try get a color from an object that we call it O, and out to B, and out color to B. Okay, so the structure is almost the same at the definition of the method, and the implementation is almost the same after this point. So we say B equals to color dot black. First we instantiate the B, then we ask if A, or here I called it O, is a color. Okay, if it's a color, then we say B equals to typecast to color our object. Ah, come on. Our object. Then we go else if object is a vector 2. Then we want to say B equals to new color of, well, before that, to make it easier, we say vector 2, and we call it V, equals to typecast to vector 2, our object. So v.x, v.y, and if we sent in a vector 2 for the color, then I would say that these two elements should be zeroed. Okay. Else if O is a vector 3, basically we are doing the same thing, but here we say vector 3v, typecast to vector 3, and this is v.z. How about a vector 4? So if it's vector 4, typecast to vector 4, and we have v.w. Okay? So basically I'm converting at the same time. I can convert vector 2 and vector 3 and vector 4 to a color here. Then let's copy the whole thing to make my life easier. If the O is a rect, then we want to be a rect and typecast to rect, and basically here we have the width and we have the height. If the O is a quaternion, then we want to say the quaternion value equals to typecast to quaternion, and again we have vxzw. Okay, and else, well, guess what? We send something that we can't typecast it to a color, and because we already assigned the black, we are okay. And at the end we return true, because if we hit here, it means that this else wouldn't happen, so one of the ifs on top had happened and we had already converted it to color. Now public static bool, try get yeah, let's go with float first. So object O out float B. We say if O is float, because that's the easiest one, we say B equals to typecast to float our object. Else if O is int, then we say B equals to typecast to int the object, and we can assign an int to a float. That's why we can do that. Else if O is a bool, then we say B equals to typecast to bool the object. If that is 1f, if the object bool is true, then we want 1f. If it's false, then we want 0f. Else if O is byte, then we simply say B equals to typecast to byte of the object, and it's again 0 or 1, so we can typecast it. Else if, come on, behave. Else if, now again I'm assuming I'm sending a string, so we say if not, float.tryparse the O.toString, and if it's possible put it on B, otherwise we return false. If this didn't happen, then we already converted it, so we return true. So same thing can be used to try get integer. But of course we are outputting to int. We are saying if O is int, then we typecast it to int. Otherwise, if it's float, we can typecast the float to int. Yeah, we will lose precision, I know. That's that. Wait, here I needed one more space, one more thing. We first need to typecast it to float, the O. That was the reason for that warning, okay? Then typecast it to int. If it's Boolean, then again we want the 0 or 1, but not float 1, integer 1. If it's byte, then we can typecast to byte. In here we say int.tryparse that, and that's our typecasting. Now, I will move this guy down because the others are really close to this guy, and copy it and paste it here. So try get rect. So and out to rect. Here we say equals to new rect. If O is rect, then we typecast it to rect. That is all we need to do. If it's rect or true, then we want a rect of vectors and with 0 height and width. I was tempted to use the x and y here to get a, square, but then I said, hey, if we are not sending those, then it should be that. So rect. Now here we say if it's color, because we replaced it to each other. So color, and of course we have R, G, B, and alpha. New rect, and here new rect. that. Okay, so after that, how about a vector 2? So try get vector 2, and we are outputting to a vector 2. B equals to vector 2, that's 0. If it's color, well, if it's vector 2, that's the easiest one. Then we want to typecast it to vector 2. If it's a color, we want to typecast it to a color. Color. Then we want a new vector 2 of VR and the red and the green, and we are throwing away the blue and the alpha. So new vector 2, actually, yeah, X and Y compartments. If it's vector 4, then we want a vector 2. That. If it's rect, we want a vector 2 of that. If it's a quaternion, I want a vector 2 of X and Y. Okay. Vector 3. Vector 3. So we out to vector 3. It's equals to vector 3, that's 0. If it's vector 3, that's the simplest thing. Do that. Vector 3. Otherwise, if it's vector 2, we can implicitly typecast the vector 2 to vector 3. If it's a color, we want to typecast to color, and we want the red, green, and blue part, and we don't want the alpha. And new vector 3. So if it's a vector 4, we want to have the new vector 3, and we don't want the W part. If it's a rect, a vector 3, we don't need the height. If it's a quaternion, new vector 3, and we don't want the W. So vector 4, vector 4, vector 4, and it's equals to vector 4, 0. If it's vector 4, then typecast to vector 4, return new vector 4, and you see that actually we can, I didn't know, we could implicitly typecast colors to vector 4s, interesting, but just to be safe, just to make the code more readable, so it's, if it's color now, we are typecasting to color, and we are returning a new vector 4 of our G B A. And what's that? Extract method code refactor provided, blah blah blah. No, whatever. If it was rect, then you vector 4, and if it was a quaternion, a new vector 4. Okay. Another one is for quaternion, of course, and that's the last try get value. So quaternion, and we want the quaternion. So for quaternion, we don't have 0, but we have identity. So if it has quaternion, typecast to quaternion, vector 2, we return new quaternion, vector 3, we return new quaternion. Actually, here I can say quaternion dot Euler, so from V, that would work. So if it's vector 4, we return new quaternion. If it's rect, we return new quaternion. And finally, if it's color, we typecast to color. R G B A, and return new quaternion. There we go. So we had finished our try get values. Okay. So I will put a to do here. To do. Add needed comparison codes later for try compare to. And that is our reflection utils for time being. Try get values, try comparing. Well, let me see if I have something that I really need to compare all the time. Well, few actually. For example, integers, floats, booleans, and basically I need them. So let's start implementing some of them, although I'm short on time. But let's remove that to do. I don't like to do's. So public static bool try compare to. Now here we know that we have a bool as a value. We don't know what is the object we are comparing it to, and we want to put it outside in another bool, and we call return type. Okay, here we say if O is bool, because that's the easiest one. Then we say ret equals to v equals to compared to actually typecast to bool the O. Okay, else if O is int. So if O is integer, we want to return v equal to v equals to v typecast to int the O, and we say if it does not equals to 0. Okay, we need another parenthesis here. There we go. So first we typecast O to int, then we compare it to not be equals to 0. It will return a true or false. Then we compare our value that we want to compare to that true or false, and we set it into this guy. Well, we have the same thing for float, but here I will cast it to float, and we compare it to 0f. After that, we are assuming that we sent in a string. So we say bool, and we call it result. Then we say if bool.tryParse or o.toString, if it happened, put it inside to our return. And if it happened, then we say return equals to, no, sorry, not inside this read, inside result. If we could parse it, then we say return equals the comparison of v with the result that we parsed. Else, we say return equals to false and return false. Basically, if we hit here, then we already converted that comparison and return true. Okay, so that's the Boolean. I will copy it because we will have the same thing, try compare to, but here instead of a Boolean, I will accept an int. And I will put at the result as a Boolean. So we say if it is an int, because that's the easy one, typecast to int and check if they are equal to each other. If it is a bool, then we want to typecast it to bool. Then we say well, basically, if typecast to bool, we want 1, otherwise 0, and we compared the whole thing with this condition. Same thing for the float, but here 0f and 1f. Otherwise, here we want an int. We say int.tryParse into result, then we compare them, then return to false. Okay. Another overload for this guy, but before that overload, I will do the same thing for the float. So we are accepting a float in and comparing it to an object. So if it's float, then typecast to float. If it's bool or if it's integer. Now for the integer, we want to simply typecast that to int. Oh, not 0. Oh, okay. And basically the rest is the same, except here we will accept a float, and here we say float dot tryParse. Okay, now an overload for this guy. Here, instead of putting it inside a Boolean, I want the result as integer. Okay? Now, if we have an int, we should say instead of equal, we say dot compare to, and we compare to this guy. Now this, if you move your mouse here and compare to, you see that it returns an integer and says that the indication of relative position of these two numbers. Okay, so for example, if the object is before the value we sent in, or the after, or being after the value we sent in, the result will be -1 or 1. If they are exactly the same, the result will be same. It will be 0. So dot compare to that, and finally, did I did something dumb here? Yeah, because it's float. Ha! Okay, we want to typecast the int what? The typecast to float of O. Yeah, that will work. I was dumb. And for sure, I have the same error here. No? Okay. So, if it's float, we want dot compare to, again doing the same thing, int typecast to float dot O, typecast to float O. Okay, this will work, but it's exactly the same thing as this. Okay, it's just more readable this way. So else, we say v dot compare to the result, and else return only false, and no. Then return type equals to 0 and return false. Yeah. Okay, so if I got 0 but at the same time it was false, then I know that it wasn't exactly the same number. I failed. That's the meaning. But if I get 0 as return type and the true as the condition, then I know that v and o were exactly the same integer values. So let's copy this because it will be easier to use this as the overload for the float. So we send in the float and we want the relative position on that float, and that is an int. Okay, so if it's a float, typecast to float. If it was bool, then typecast bool. And if it's int, basically we are typecasting to int. Otherwise, we float.try parse inside a float, and we are comparing them to each other. And just by that, we almost finished all the comparisons I want. I had a character comparison, but honestly, because we are not using any characters in our font, awesome, we don't need that. And I have a problem here. Why you are not happy? Exception E. I forgot that. Okay, now here, if object does not equal to null, use null propagation. It will convert it to something like this, but I found that Unity won't, Control Z, Unity won't behave properly on that. So I just need to, disable this guy, and I will get rid of any warnings, anything there. And that is our reflection util, guys. So we can get a value, set a value, get a field, set a field, get a member type, get a member value, then set member value, get public fields, get public properties, both of them, get the type of a string, and compare stuff to each other, and try get different values from an object. I hope you enjoyed this episode. In next episode, I will work on my conversion utils. Have fun, everyone. Bye-bye.